Problem 12. The arrows on the two spinners shown below are spun. Let the number n equal 10 times the number on spinner A added to the number on spinner B, and that's equal to n. What is the probability that this n is a perfect square number? So, first of all, how do we express 23 in terms of the sum of numbers? Well, that's equal to 2 times 10 plus 3. The idea here is that this place is 10 to the 0, and this spot is 10 to the first. So therefore, if we want to expand it, that's 2 times 10 to the first, right, plus 3 times 10 to the 0. Wait a minute, what does 10a plus b look like? Well, that looks like exactly the expansion of a two-digit number in base 10. So in other words, when we do 10 times a plus b, that's given us a number that's in the form of ab. Because if we expand the number ab, a and b are numbers from 0 to 9, that must give you 10a plus b, right? And that must give you n. So in other words, this n right here is just equal to the number of ab. So in other words, what can we say? We can basically just say, given this information, that any number we get on spinner A just goes to the 10th digit, and whatever number we get from spinner B goes to the units digit. That's what enables us to get a perfect score in the first place. So let's first understand the definition of a probability. The probability of something is just equal to the number of successes over the number of total cases, right? So what is the number of total cases? Well, the total cases is the total number of two-digit numbers that can be formed from the two spinners. Well, every spinner is offering 4 individual numbers. Now we can just do 4 times 4. Why? Because in spinner A we have 5, 6, 7, 8. And in spinner B we have 1, 2, 3, 4. They're all distinct numbers, so we don't have to worry about overlap. So 4 times 4 gives 16, and that will go to the denominator 16. But what is the total number of successes? Well, it has to be a perfect square. So let's just count it up, right? We can have, well, 5. What perfect square has a 10th digit of 5? Well, on top of my head, 7 squared is equal to 49, right? And we know 8 squared is equal to 64. So obviously none have a perfect square where the 10th digit is 5. So we have one, however, where we have an 8 squared, which is 64. So let's box that in to indicate that. 7 squared is too small. What about 9 squared? That's equal to 81. Well, 8 and 1, that would work, so we have 2 cases right now. But wait a minute, what is 10 squared? 10 squared is 100. That's too big. We can only have 2-digit numbers. So 2-digit numbers, well, 7 squared gives 49. That's too small. 9 and 10 squared is too large. So that means 8 squared and 9 squared are our only possible successes. Therefore, we have 2 total successes. So 2 over 16 gives you 1 over 8. So your answer choice is answer choice B as your final answer.